Hi there, hope you have a fantastic day today. This lesson I'm going to teach you how to graph a gradient functions of a curve. Of course, you can work with me by download the PDF file versions on the description below. Otherwise, let's go straight into it. Before I go through some of the examples, so let me just recap a few things first, okay? So first of all, we know that if the line goes this way, so we have a positive gradient, which is m is greater than 0. So if the line goes this way, so we know that the gradient is negative. So that is the gradient is less than 0. And a horizontal line, so that is m is equal to 0. And a vertical line, of course, m is infinity. So let's go through a few examples. So the first one is, you can see the line gone this way. So we have a positive gradient, right? But the thing is, it's a straight line. So therefore, the gradient at this point is exactly the same as these points. And this point and this point. They all have the same gradient. And the gradient of this is a positive constant. And we don't know what it is, okay? So therefore, the gradient functions of this straight line is a horizontal line above the x-axis because it's positive gradient, okay? So let me just draw it. So this is it. Anywhere, okay? It could be here, 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 anywhere, because we do not know the gradient of this function. So let me just draw a straight line somewhere there. So this is f dash x. That is the gradient functions, okay? So we label this is x. There you go. Second one. Now to work out the gradient function of this, the first thing is we need to identify the zero first. Zero gradient, okay? So this graph here, we have a zero gradient at here, okay? So at this point. So therefore, very important, we need to identify this first. So along the x-axis, which is when x is 0, okay? That is, the gradient is 0. So along here, when x equals 0. So when x is 0, the gradient is 0. So let me just label this first. So 0 here has a gradient of 0. So f dash x. And this is x. So if I use ruler to work out the gradients, so you can see along here, the gradients is increasing. You can see, all right? So when x increase, the gradient is increased. So you can see. And toward the top, it's like almost infinity. And then let me just write the sign for you. So it starts small positive and start increasing. Okay, so it's going bigger and bigger gradient. Okay, so the positive gradient, and is it increasing as x increase. Similarly, okay, so we start less negative and then we have more negative. Okay, larger negative gradient if you like. So you can see, and it goes steeper and steeper as in x decreases. So now to do this, so first of all, we label this first. And then what it does is start increasing like this. Start above the x-axis, going up like this. And then this one, 0 gradient, and start decreasing. It's like this. So it is a straight line. So let me just use ruler to draw it. So roughly, it's just like this, okay? So we're not sure what the gradient is, but it just roughly is a straight line. So this is f dash x, the gradient functions of the parabola. So please note so far. So if we have a straight line, okay, the gradient function is a constant, a horizontal line, okay? So you can see a parabola. Let's say this is fx is equal to x squared. And the gradient function of this could be anywhere, kx, okay? So just keep that in mind. Now, third one. So similarly, to do this, we need to identify the zero gradient first, okay? So at this point here, we have a zero gradient here. The gradient is equal to 0, okay? So let me just use ruler to line up first, okay? Very important. So step number 1, I just identify the 0 first. The 0 gradients. So there you go. And then after that, we know that this gradient here is positive. Remember, the line going this way is positive gradient. So you can see by using the ruler, so tangent of this curve here, so positive. So go down here, even greater positive. And you go down here, and it's almost infinity. So there you go. So to get this, so we here is very large positive gradient. So we got to start up here somewhere, okay? And then we go down all the way, hit 0 here. And then we keep on going down and have to be hit 0 at here with the gradient. So therefore, it have to go, start from top, it go down, and then we go up, okay? So start from up here. So we start up there somewhere. We go down, and then we go turn, because we have to hit the 0. So we just keep going up. And don't forget, this is the gradient functions. And this is x. There you go. So you can see the graph is correct because the gradient of this is positive. So therefore, from here to here, above x-axis is positive gradient because this is the gradient curve graph. And the gradient of this part is negative. See, there you go, at some point. And then this part is positive gradient. So you can see this graph here is a cubic function. So if you graph the gradient functions of a cubic function, it gives you a parabola, okay? So just keep that in mind for me. Next one. So rather than draw a gradient functions underneath of the curve, I'll just draw on it, okay? So it just makes it easier for me, that's all. So let me just label this f dash x as well, the gradient functions. So to graph a gradient functions, the number one rule is we need to identify the zero gradient first, okay? So just keep that in mind. So we just make sure the zero gradient first, okay? Along here. And this is zero gradient here. And this is also another zero gradient at this point. So there you go. So now we know that this gradient here, this part here is positive. So 0, and then we start, this one here is infinity gradient, almost, right? So a large gradient. So it's up there somewhere because it's f dash x. You start from there and you go down and you hit 0 and you have to turn up because we have to hit the 0, 0. And then going up and going down because we have zero gradient here, somewhere like this, and we just keep going down. And that's all. That is the gradient functions for this curve. Then you can see the gradient of this is negative. So this from this onward, right? So this is 0. And this part is positive gradient. And this part here is negative gradient. We have this. And this part here is positive gradient. So we have positive gradient here. There you go. Please pause the video and try it yourself. Hi, I'm back. How do you go? So let me go through it with you, okay, to see whether you got it correct or not. But before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into this. So the first thing is we need to find the zero gradient, okay? Gradient is equal to 0. So at this point here, the gradient is 0. You can see that, right? Turning point. So therefore, let me just quickly draw on this. And I draw on the function, okay? It just makes it easier, that's all. So I need to label. So this is f dash x, okay? The gradient functions. So 0 is here, first thing. And then we have this side here is positive gradient. You can see, okay? So positive gradient, and in here is a large positive gradient. So at this point, we gotta start somewhere there. And this part here, we have negative gradient. So we start from 0, and then we keep decreasing like that. So it is a straight line, okay? So just keep that in mind. And if the function is a parabola, the gradient function is a straight line, okay? Just remember that for me. So let me just use ruler, and we just roughly, okay? So just a straight line roughly across there. That will do. So this is f dash x. There you go. Please pause the video and try this one yourself. Hi, I'm back. Let me go through it with you. So the first thing we need to do is identify zero gradient. So the gradient 0 here. So at this point, okay, roughly. I draw on the graph, okay? So it's just easier, that's all. And we have a 0 gradient here and roughly 0 gradient here. Okay, you can use ruler and lining up if you like. So that's it. So now you just look at this. Okay, this part here is positive gradient. So we need to start up there somewhere. And don't forget to label because this is gradient functions. Okay. And then what happened is we go down here. 0, of course, hit 0 and going down and going up. And this one also negative gradient. So therefore we have to turn back. Okay, we have to turn back somewhere there and going up somewhere like that. All right. So let me just redraw this for you. So we start up there and we just go down, hit the 0 somewhere around and going back again. And of course we need to hit the 0 here. So we go down somewhere and going up. There you go. So your graph should be something like this. Please pause the video and try this one yourself. Hi, I'm back. How do you go? So we know that this function is a straight line. So therefore, the gradient function of this is a constant. And this is a negative constant because remember the line on this way, we have a gradient of negative or less than 0 if you like. So we just draw a horizontal line, but it's negative. So therefore, it's below x-axis. So let me label this first. Very important. This is gradient functions. So we need a horizontal line, a constant if you like. So this is it. And below x-axis. And we do not know where it is. So just roughly, okay? Somewhere there. Doesn't matter where it is, okay? But have to be below x-axis. So this is it. There you go. That's it. Thank you so much for watching. Bye.